Hi, welcome to another video. In this video, we will learn about how to calculate allowable wind speed for lifting operation. Wind speed affects the rig load drastically and it can lead to severe consequences if not dealt with care. Let's talk about the factors which are significant about the wind speed calculation. Number one is the meteorological data, that is the weather reports. The second one is the lift height. Third one is the manufacturer wind speed mentioned on the crane load chart. And the fourth one is the geometry of the load. We can get the meteorological data from various sources from the Google or weather reports from the Google or from the website. I usually use the website which is called windfinder.com. So let's say that we are working at 9 o'clock and the wind gust is 6 meter per second. So in meteorological data about the wind speed, we always consider about the sudden burst, which is called the wind gust, which can last up to 20 to 30 seconds and have enough time for the to affect the crane and the load. So in that, if you can see in that meteorological data from the wind finder, we have other sources also available, like the temperature, the tides. If you are working in offshore, then you can also measure how much is the high tide or the low tide, which can help you for your planning operations. For the lift height, in our horizontal axis, we have the height from the ground level, and on the vertical axis we have the multiplication factors. So let us assume that our load movement is up to 20 meter of height. So as per the graph, this is 20. If we follow this line, green line, to the up to the curve, it will meet up to 1.2. So the multiplication factor is 1.2, and the actual wind speed as per our meteorological data was 6 meter per second. So we need to multiply with 1.2, and now we will consider our wind speed is 7.2 meter. Let's consider manufacturer load chart. This is a manufacturer load chart on our left hand side. So we are working at 16 meter of radius with 41.3 meter of boom, and here our capacity is 7 ton, and on downside we have a wind speed of 11.1 meter per second. So let's talk about the geometry of the load. The drag force affects the load with reference to the geometry of the load. Different geometry of the load have the different drag force coefficient. So if we discuss the drag force in simple word, it is the frictional resistance of the body of the load with the wind waves. So here we have a different geometry of the loads, and we have the drag coefficients. For plate, shutter and shuttle sheet piles, we have a drag coefficient of 1.222, and when we have a ball spherical reservoir, it's 0.3 to 0.4, and silo reactor vessel, it's 0.6 to 1.0. So the safe practice is always take the maximum drag coefficient, which is 2.4. We will apply the formula, which is the allowable wind speed is equal to WLA multiplied by 1.2 multiplied by the mass under root divided by the surface area, which is AP, multiplied by CW, which is the drag coefficient. So WLA is the maximum wind speed as per the load chart. M is equal to total weight to be lifted. AP is the total surface area, and CW is the drag coefficient. Now, what is AP? AP is the maximum surface area. We will consider the maximum which is exposed to the wind speed. Let's say we have a container of 20 feet, which is 6 meter in length and 2.5 meter in height and 2 meter in width. So we have the maximum area now is 6 multiplied by 2.5, which is 15 meter square meter. So we didn't consider 2 meter into 2.5 because it's the less exposed surface area, and 6 into 2.5 is the maximum exposed surface area. So we will always consider the area which is the maximum exposed surface area of the load. So we will put the values in the formula. So the allowable wind speed is 11.1 as per the load chart. The weight is 4, surface area is 15 square meter, and the drag coefficient is 2.4. After solving this equation, we got the answer is 4.05 meter per second. Here there is one note: if the weight upon surface area is more than 2, then we have to plan the lifting operation as per the wind speed given in the load chart. If it is less than 2, then we need to consider this formula. Now let's come to the conclusion. The weather prediction and the height multiplication factor of the wind speed is our allowable wind speed is at that point is 7.2 meter per second, but as per our calculation our required maximum wind speed is 4.05. Here now the actual wind speed on the weather forecast is 7.2, and as per our calculation is 4.05. So therefore it's not safe to proceed as it is 3.2 meter per second above our allowable maximum wind speed. This is all for now. Please don't forget to like, subscribe, share, and don't forget to press the thumb icon button and also the bell icon button. Thank you.